Hello, and welcome to EC&M Asks, a new Q&A video series in which readers pose their most pressing electrical questions and our subject matter experts answer. I'm Tommy Northcott, Senior Power Engineer and Branch Manager with Jacobs. I'm here today to answer some of your most common questions about arc flash hazards. So let's get to it. The first question is this. I have always been told that arc flash PPE isn't available above 40 calories per centimeter squared due to the fact that the arc blast is large enough to kill the worker. However, recently someone showed me that there is PPE that is rated 80 calories per centimeter squared and above. Is it ever safe to work above 40 calories per centimeter squared? Well, this is a very complex subject, which has had much misinformation associated with it over the years. The reality is that the issue actually is due to two different hazards, arc flash hazard and arc blast. The arc flash is what the 40 calories per centimeter squared is referring to. It's a measure of heat energy or the temperature of the arc flash event. Arc blast is the associated blast pressure from the arc flash event, which, for various reasons, is not measured or calculated. So from an arc flash perspective, you can currently buy arc flash suits rated at 140 calories per centimeter squared that will very effectively protect you from the heat produced by that flash. However, the difference comes from how you get to those high energy levels. The arc flash energy increases predominantly due to two factors, your available arcing short circuit current and the duration of the fault. A high available arcing short circuit current scenario will result in very rapid increase in energy, which can cause an arc blast, which could reach deadly pounds per square inch forces. On the other hand, a low available arcing short circuit current with a long clearing time can result in a ramping up to the high incident energy, which does not produce as much of blast energy along with the high heat hazard. The challenge is, in the field, there is no way in which the worker can know what the driver is behind this incident energy value, so you don't know if there's a potential for a deadly blast or not. Someone knowledgeable in arc flash incident energy calculations could determine that if needed, but in lieu of knowing the reason for the high value, I still recommend not exposing personnel to hazards greater than 40 calories per centimeter squared. The next reader asked, how should I determine the required arc flash PPE when electrical equipment is arc rated or arc resistant? This is a good question with multiple answers. First, let me say that you should know and follow the manufacturer's recommendation for operations and maintenance of arc-rated electrical equipment. There's a lot that could be explained about arc-resistant gear, but it's important to note that the safety features of the gear depend on its rating. For example, the gear could be rated safe from the front of the gear only, or rated to be safe on all sides during normal operations. The gear is designed and tested to either fully contain the arc flash within the gear or to divert the arc flash energy to a safe place to be released. Some designs may direct the energy to be released out the back of the gear, which is one of the reasons to be knowledgeable of the design features of the arc resistant gear. It is also important to know that arc resistant gear is typically only arc resistant during normal operations with specific doors and enclosures properly secure. For the case of maintenance, you typically need to do an arc flash assessment as if it were non-arc resistant gear and protect the worker in accordance with the calculated incident energy level. Another reader asks, what about arc flash hazards for systems less than 480 volts, like 122.08 distribution panels? Well, the IEEE 1584 is the guide for performing the arc flash calculation, and it explicitly limits its scope to three-phase systems from 208 volts AC to 15,000 volts AC. For three-phase 208 systems, the arc flash calculation methods are defined in the IEEE 1584, and you follow the same general process that you would for 480 volt systems. For common single-phase systems, less than 480 volts, there typically isn't enough energy to sustain an arc sufficiently to propagate into an arc flash. So those systems are not considered to be arc flash hazards. Well, in an effort to keep these videos short, it looks like we're out of time for today. We'll pick up again with more answers in the future, and we thank you for joining us for this edition of EC&M Asks. Thanks, and have a great day.